Working okay? Great. All right, we'll go ahead and get started. Thanks everyone for coming on the last afternoon of the conference. I appreciate it. So my name is Andrew Guibert. I'm a software engineer at IBM, and today I'm going to be talking to you guys about streamlining your integration testing with test containers. So before we get into the technical details of the talk, and I show you code and whatnot, I think it's important that we start with the motivation of why we are doing this. Why do we talk about testing? Why do we even write tests in the first place? Is it because we love to see the green bars when all of our tests pass, or is it because we want to have 100% code coverage because our manager tells us that that's what we need to do in order to write safe code? Those might be some motivating factors, but that's not the main reason. I think I spent some time thinking about why we write automated tests in the first place, and the short answer I came up with is to have confidence that our application works the way that we want it to when it's in production. If we were all perfect programmers, then we wouldn't need to write any tests. We would just make the code change, push it straight to production, and then leave work on Friday and then not get called out at 2 a.m. by support. But none of us are perfect, so we need to write tests to make sure that our code is working the way that we want it to. So looking a little bit deeper on that question, there's a lot of types of testing available to us. So what type of testing gives us the most confidence? So I'm sure a lot of you have seen pyramids similar to this. This is kind of my rendition of it. So at the base we have unit testing. This is like the smallest, easiest typical thing to write. Usually it's just JUnit, maybe a few other libraries when you're writing Java tests. And they're very quick to write, they're fast to run, and usually they just test usually one or two methods at a time per test case. And then going up the pyramid a little bit, we have integration testing. That's where you have multiple test classes or components that you're testing at once. Sometimes you'll get mocks involved and some helper libraries. And then at the very top of the pyramid, we have system and UI testing. And this is where, like, if you're running on a server, you actually boot up an instance of the server and make sure that the actual HTTP requests are working properly. Or if your application has a user interface, this is where you would do some user interface testing. So just by show of hands, who thinks that unit testing gives them more confidence? Yeah? Okay, so about half the room. And who thinks that integration testing / system testing gives them more confidence that their application works? Okay, so about the other half. So I ran a survey on Twitter with this question, and the dominant answer that I got, I only gave two options, unit testing versus integration testing, and overwhelmingly the response was that integration testing give developers more confidence that their application works the way they want it to. And I think the answer is pretty well summed up with this picture here. So this is a sink that is, if we wrote some unit tests for this, the sink turns on, the faucet turns off, the drain works, the sink doesn't overflow. All the individual pieces are working just fine, but as a whole system, it's not working properly. If a plumber walked out of installing this sink, the customer would not be happy, even though all the unit tests are working properly. And as programmers, we shouldn't be expecting our users to be happy with just unit tests. They don't care if the little pieces are working properly. They want the whole system to work properly as a whole. So unfortunately, this is kind of a more realistic testing pyramid of what I end up with in some projects, where we write unit testing because it's what we can do right away with our code. They're easy to do. Integration testing and system testing are a lot harder to do. Usually, if you are on deadlines, that's the type of stuff that will get pushed to the end or maybe fall off entirely. And the dreaded manual testing, right? No one likes that. So I want to look at why that is. So I drew a little graph here. On the bottom, we have the amount of time we're given and the amount of confidence we have in our testing. So I think it's a pretty safe assumption to say that the more time we're given to work on something, the more time we have to write tests, the more confidence we have that it works properly. But, of course, we have a fixed amount of time, so that's the amount of confidence we end up with in our testing. There's a couple factors that can influence this, such as internal culture, the way that your management is giving you deadlines and things like that, or how many users you have that are demanding load on your system. But one thing that's pretty universal to all of us is the tools that we have available to us. And factors like these can allow us to be more productive writing our tests and have a higher confidence in our tests with the same amount of time that we have. So I want to put a pin in this for a minute and talk about another thing that's important with microservices and modern applications, and that is a manifesto that was published called the 12-Factor App. So some of you may have heard of this before. If you haven't, these are the 12 factors that comprise the the whole piece. And I'm not going to go into all of these on detail, but what I am going to do instead is kind of focus in on factor number 10, and that is Dev Parody. So let's look at what exactly is Dev Parody. So the idea with Dev Parody is to keep your development, staging, and production environments as similar as possible. And usually, offenders of Dev Parody are violating one of three rules. So either there's a time gap, so the amount of time it takes you to write a code change and to get that code change pushed into production can cause issues because there can be more changes in the code base or the tools that you're using between when you make the change and when your change hits production. Also, there can be a personnel gap, so that would be if you have a developer writing and testing the application locally, but then you have some ops engineer actually deploying it in production, and they might configure things differently. And then there's also a tools gap, so we might be using one software stack locally in our development environment because maybe it's faster and it's more convenient, but we might be using a more robust software stack in production. So here's a useful quote from the 12factor.net website, and this says, "The 12-factor developer resists the urge to use different backing services between development and production, even when adapters theoretically abstract away differences in backing services." And I think a good way to sum this up is the excuse, "It works on my machine." So I've heard this one a lot in the software industry. It's probably the most dreaded problem to debug because it's very frustrating to work with. And if you're doing Dev Parody properly, then you will minimize these kind of excuses. So next I'm going to show a piece of code that my organization wrote for one of our guides. So I work in IBM on the Open Liberty project. It's an open source application server. And this is a sample application that we wrote. And there's a bug in the code. I will give you guys a little bit to look at it and see if you can spot what's wrong. Just think to yourselves. So this is kind of a trick question. The code can work perfectly fine, but it can have a bug in it depending on how we're deploying it. So when we wrote this guide, we were using a local Maven build with an exploded file system, but in production, we might be deploying this application in a Docker container. And what the developer had done here is they were reaching into the target folder for a specific resource. So as we know, if we've ever done a Maven build, it usually publishes artifacts to the target folder. That's where all of our build output goes. So it was reaching into that build output folder and using a resource from that, but they didn't realize that when we deploy in production, then that resource is not available because we've packed everything down, not the entire target folder, probably just the jar or WAR file that has the actual application code in it, and then we're only using what's in the Docker container in production. So another common issue is databases. So lots of applications use databases, and very frequently we'll use a database like H2 for development and PostgreSQL in production, or we'll use something like Apache Derby for development and something more robust like IBM DB2 in production. And going back to the 12-factor quote earlier about the theoretical abstractions, Apache Derby and DB2 were actually both developed by IBM, and they were specifically designed to have the same communication protocols as each other so that they would be compatible abstractions. But even though this special effort was made to abstract away, so you could use Derby in development, we still run into issues such as like transaction locking problems in DB2 where they're not seen in Derby for our local development. So I think it's important to use the real services that you're using in production in your local development environment, or at least your staging environments, definitely. So why do we do things like this to ourselves? You know, it's kind of obvious that we should want to be running as close to production as possible. We use H2 and Derby and things like that in development because it's easy to set up. It's a lot faster to start than the real thing. We have DB2 Docker containers now, but they still take like 30 seconds to start, and you might not want to wait for that if you're doing rapid development on your local machine every time you run those tests. And we've been doing it this way for like more than 10 years. So I think 10 years ago, using abstractions like H2 and Derby probably were the right answer, or rather the best answer at the time. But like any programming paradigm we have, it's important to reevaluate the decisions that were made and make sure in the current time that they're still relevant and that they're still the right answer. So if we think about the Dev Parody and how we used to test software versus how we could test software today, the big new technology or the big new player in the game is containers. So a lot of us run containers in production these days. They're very convenient. They combine everything you need to run a particular service into a single unit. There's an easy standard way to manage them with orchestration software like Kubernetes. They're lightweight and disposable, and they're fairly easy to configure with environment variables. There's an easy way that we can leverage containers in our testing environments using a helper library called Testcontainers. So Testcontainers is essentially a Java plus JUnit abstraction that wraps the Docker API and allows us to easily use code like this in our tests. So this is just a couple lines of code here. It's just a JUnit rule. And what this does is before the tests run, it will actually start up a PostgreSQL container with the indicated database name, username, and password. And the person who runs this test, they need to have Docker installed on their machine, but they don't need to know anything else about Docker. They don't need to know any of the commands or how to configure Postgres. So I'm going to cut from the slides for a second here and just show you a quick example of what this looks like in action. So here I have a standard JUnit test case that's just like the one I showed you on the slide. So we have the Postgres definition along with the test case. And can the people in back see that okay, or do you want it bigger? Good? Okay. So in my test case, I can just get a standard JDBC connection from this container and start issuing SQL statements on the container. And this all runs fairly quickly. If I do a Maven verify, this will just run your standard Maven integration test, and we'll see that we get the container output right in our log. So the first thing it's doing is it's checking to make sure Docker is installed on my machine, and then I have compatible Docker versions, sufficient disk space, things like that. And then it actually starts up the containers, waits for some readiness check, and then once the containers are up and ready, then it will allow my unit test to run, or my integration test to run, and then after the tests are done, it will shut down the container. So Testcontainers has a lot of cool extensions for it. Here's a few of the icons. So we've got pretty much every database, some messaging engines. Pretty much anything you can put in a container can be used with the Testcontainers API. Personally, inside of IBM for our Open Liberty development, we've used this for abstracting away a lot of our database machines. So we used to have to manually maintain external database machines to run our tests against, but now we've switched to using Testcontainers, and we don't have to worry about the manual maintenance anymore because we just spin up a new container for every test, and we get a perfectly clean instance every time, and we don't need to worry about operating system patches or logs filling up or things like that. So Testcontainers is great, but after I saw this, I was thinking about how can we take this a step further and use it for testing applications as well. So I started a library called MicroShed Testing, and the motivation here was particularly for Java EE and MicroProfile developers to give them an easier way to test out their applications the way they run in production. So I ran the same Twitter survey from before. I said, why do people lack confidence in their tests? What are the main issues we see here? And the #1 issue was that our tests don't accurately reflect the way our app runs in production. So Dev Parody was an issue for people. Also, writing the test takes too long. It's just too complicated. And likewise, setup for the test is too complicated. You have to install too much stuff, or there can be brittleness. So when designing MicroShed testing, I took these points into consideration. So I wanted MicroShed testing to be easy to set up. I wanted it to work with any application server, not just Open Liberty that I work on. And I also wanted to give Dev Parody, so give people true to production tests through containers and through the test containers library. So here's kind of an overview of how the whole thing works at a high level. So we have the test containers API that controls the Docker network, and it can orchestrate, do simple orchestration of containers. And then we have convenience libraries for interacting with those containers like REST clients. Additionally, I put some JUnit extensions on top of that to make it kind of nice, and then users can write their test code on top of the MicroShed testing APIs. So suppose we have a simple application here. So this is a JAX-RS application that's just a CRUD endpoint on some JSON data. And suppose we want to test this out the exact way it runs in production. We can write a MicroShed test that looks like this. So there's the only extra stuff that you don't see on the screen here is the adding a dependency in my POM file. So there's no config files hiding anywhere. Nothing else. Is just pure Java code for testing a full-blown Java EE or MicroProfile application. So to break this down a little bit, the first point is you define what container you want to be testing. This is kind of defining where your application lives, what its context root is going to be, and how you wait for it to be ready. You can provide a container label if you've built an image already and it's available in a Docker registry somewhere, or you can issue a local build of that container. Next, you can also supply a readiness path manually. The next thing from the slide earlier, the person service that you saw within the application, MicroShed testing can actually generate a REST client proxy for that class. So when you write your test and you invoke methods like createPerson, it looks like a regular Java invocation, but actually what's happening is MicroShed testing is taking that Java method call, translating it to an HTTP request, firing it off to the container, and then getting the response back and potentially parsing that JSON response as a plain old Java object using libraries like JSON binding, which is part of Jakarta EE. So next, I'm going to cut back to some code here and give you guys a quick demo of what it looks like. So how many people in the room here use Java EE or MicroProfile applications, or just Java applications in general? Yeah, okay, good. All right, so what I've got here is pretty much the application I showed you on the screen, on the slides. This is just a simple JAX-RS application, nothing special there. And here is the MicroShed test that you saw in the slides as well. So to give us a run, I can just run maven verify, and it will download all the containers that are needed to run these services, and it will wait for them to be ready, and then it'll run the tests against those containers. So in this case, it's using the Open Liberty server. So that'll run in just a couple seconds. And I'll show you right after this how we can speed this up to make it a little more efficient for your local development. So that took 22 seconds. So now I can go over to my Docker file. This is how MicroShed testing knows what container to build to run for my tests. And I'm going to comment out the Open Liberty lines, and I'm going to switch to running with Wildfly. So if I haven't changed anything else in my code, the tests are still the exact same. I just changed the Docker file, and now I'm rerunning the tests, and we'll see instead of Open Liberty messages coming through in the log, now my application is testing using a wildfly server. So this is kind of one of the benefits of Java EE and MicroProfile applications is they're standard, portable, can work on multiple different implementations if you ever want to switch in the future. So another nice thing we have about Liberty, so I'm just going to swap back here to using Liberty, is we have a new Maven plugin called Dev Mode. So I can launch a Liberty server in Dev Mode here, and it will actually start up a server that's running my application, and it will listen for changes on my file system. So if I want to, say, add a feature to my application, I'll go here and I'll add a new REST endpoint. So I'll say get path hello, and I'll add a new method called say hello, and I'll just return a simple string. Like that. And now Dev Mode has seen that my IDE has saved that file, and the IDE has recompiled that file, and Liberty Dev Mode has seen that file change and it's updated my application in about 0.3 seconds is how long it took for the app to update running on my machine. So then I can go over here and write a test case for that new endpoint I added. So I'll say test hello, and I'll just assert equals hello, and I'll call the person service say hello. So this looks like a standard unit test type call, but what's actually happening here is if I rerun these tests, it's going to invoke an HTTP GET request at my running application server and then get the JSON response back. So if I go to a web browser here, and I think I'm at localhost 9080, my service. Oh, I think I'm at app. Hello. Oh, maybe not. Oh, my service people, there we go. There we go. So this is essentially what the test case is doing. It's invoking an HTTP request, and then it's just checking what the response is. But this is a way my end user would kind of interact with the system. So it can be viewed as a system level test. So the last thing I'm going to show you here is a more complex test that involves a database, because a lot of times we don't just have one isolated service that's by itself. We have more services that it needs to interact with. So I'm just going to swap to a different branch here and start up Liberty Dev Mode again. That'll just start the server. And if I switch over to the code, what I've done here is I've kind of combined the two concepts from before. So I have a PostgreSQL container, like you saw in the earlier slide, and then I'm also combining that with the MicroProfile application you saw in my second demo. So these two containers are both going to be started for my test, and they're configured to talk to each other. So in production, I'm going to be doing configuration through environment variables, so I can change whatever my database host name or password is, and then I'll feed that into my container as an environment variable. But you'll see here the other code that I have is the exact same, so that the test side code is still just invoking HTTP requests, and it's still just getting the JSON response back. But if I look at the application code here, I'm actually using a real database with JDBC here. And I could be using JPA, MongoDB, whatever database, it doesn't matter. From the perspective of my system test, I'm still just making those HTTP requests and getting the response back. So if I go in dev mode here, and the server's running, so I can make changes if I want to, I'll hit enter, and that'll run the test. And since the server is already running, it won't start one up, it'll just reuse the existing instance. But since there's no PostgreSQL running, it will start up an instance, run the test, and then shut down the Postgre container. So you'll see that ran in about 9 seconds, and that's using an actual database. So there's an interesting feature coming up in the next month or two from test containers that will allow us to reuse containers like your database containers across multiple test runs, so across multiple JVMs, and that should trim this runtime down even further to like less than 3 seconds per run. So we'll get very rapid, almost unit test speed system tests, which will be super helpful. So I can just hit enter here again, and then it will just do the same thing. It'll start up the Postgre container again, run the HTTP based tests, and check the results. So that's all I have for you guys today with demo. If you want to learn about this further, I have some resources here, so if you want to take a picture of any slides, take a picture of this one. I've got the demo link up there, as well as the slides are available as well. And I have links to both the MicroShed and the test containers repo. So if there's any questions, I can take those after. If not, thanks for coming and have a good rest of the conference. Did anyone have questions? Yeah. Yep. So the question was, with test containers, can you wrap any container? And the answer is yes. You can. Yeah, you can provide. So at the foundation of the test containers API is a class called generic container, and that you can just in the constructor. So I can swap back a few slides. Yeah. So here. So here we have PostgreSQL container. Instead of that, I could define a generic container, and in the constructor to that, I could just pass in any arbitrary Docker image label. Yeah. So like if you want Alpine colon 3.5 or whatever, you can get any container that way. The extra value add, so that's great from test containers on its own, and then they also have like the dedicated wrappers like this. So if you're working with a database like PostgreSQL, for example, and I wanted to spin up an instance, I would need to know more than just the image label. Like I would need to go read their docs and say, oh, what environment variable do I need to use to set the username, and do I need to set the password? And if test containers has a dedicated wrapper for you, it's very convenient because it's all right there in the Java doc, and sometimes they'll even do cross-parameter checking for you within the Java layer before they even try to start the container. Yes, so they have an integration for Docker Compose. So you can point at your Docker Compose, I think it's a YAML file, and it will just start up all those containers and wait for them to be ready. Another thing that we have with MicroShed testing is if you have, so say I have multiple containers defined here, and I don't want to restart them for every single test class. Say I have like 20 test classes. You can put a class level annotation on your test class that basically removes the @container and the public static field all into one separate class. So you can have one class with all of your container configuration and even configure to start up those containers in parallel. And then that sort of environment setup will be reused for all of your tests. And then the documentation on how to do that is at the MicroShed website. And then there's also documentation on the test containers website if you want to know further about that. So, any other questions? All right, thanks everyone.